Ew.
We're going to continue writing the definitions that you're going to need this year in geometry. So today we're going to be looking at polygons. Polygons look like this. So they have something in common. This is not a polygon over here. So if we're going to look at these two things, what do these have in common that these don't?
They're
You got connected, right? Are these open or closed? Okay,
closed.
these are closed. And then they meet up at these vertex points like that. Here's one that's open. Here's one that continues on. The line segments continue on like that. So polygon's just going to be a closed.
Wait. If you connected the one that crosses, if you connected it like,
No,
would that be a polygon?
You'd have two polygons there.
Okay.
Yeah. So it's a closed figure in a plane. And that's kind of a loose definition because closed figure in the plane because there are different types of polygons and classifications of polygons, and so we just kind of keep it real broad like that. So today you're going to be defining polygons. We have to look at some different parts of polygons that you're going to be investigating.
Should it be a closed straight-sided figure?
Yeah, so a closed figure in a plane made up of line segments. So yeah, you have line segments. You wouldn't have a curve to make a polygon because the sides are going to be line segments. Okay. All right. Here are some features of polygons that you're going to be looking at. As we talk about the polygon, this is called a side. So you have a side. This right here, the corner, is called a vertex. If you have a line segment that is connecting two vertices, and it's not a side, that right there is called a diagonal. So I'm going to write something down for this one. Okay, what's a diagonal? It's a line segment that connects two, now here's something we have to define as well, non-consecutive vertices in a polygon. Okay, so we have to just figure out what this consecutive is, non-consecutive and consecutive. Okay, so if you look at a polygon, and let's go ahead and label the sides 1, 2, 3, 4, and let's go ahead and label the angles A, B, C, and D.
Is it a polygon or a square?
A square is a polygon, yeah. Sides that are touching each other or right next to each other, these are called consecutive sides. Consecutive sides. So like side 1, side 2 are consecutive, side 2, side 3 are consecutive, side 3, side 4 are consecutive, side 4 and side 1 are consecutive. So they are touching each other, they share a vertex. Okay? Now consecutive angles are angles that are right next to each other too as you go around. So those are, angle C and angle B are consecutive angles. Now, a non-consecutive means that
Means that they're not connected.
they're not connected. If you look at two consecutive vertices, so like let's say you look at this vertex and the line segment connecting them, what's the line segment connecting two consecutive vertices called? What's this thing called?
A line.
A side. Okay? So a side is not a diagonal, so that's kind of how you differentiate between that. Two consecutive vertices connected by a side, but the diagonal is two non-consecutive vertices. Okay? So that's kind of tricky. What else? You have concave and convex polygons. I'm going to erase this. Everybody got it?
Yeah.
So that word consecutive means in order. So like 1, 2, 3, 4, 5, 6, those are consecutive numbers. Okay? All right. And then the last two that we have to talk about are convex and concave polygons. Okay, concave and convex polygons. Or is that part of your lesson? Okay, convex polygons look like this. Concave polygons look like this.
She pissed me off.
Now, convex polygons, the ones you're kind of used to seeing. Concave polygons are a little bit unusual. If we start looking at the diagonals, like here's the diagonal there, there's a diagonal, connecting non-consecutive vertices, there's diagonals. Start drawing the diagonals to this, you have a diagonal here, put a diagonal there, you have a diagonal outside, because that's a non-consecutive vertice. You have more diagonals, I'm not drawing them all, but here's another diagonal that's outside. So these concave polygons have a diagonal that's outside the figure. So these have a diagonal that's outside. Okay, all right, now we're ready to go. Those are the pieces that you kind of have to know to do this. You're going to be doing the exact same thing you did on Friday. You're going to be doing some definitions. A blank is a blank that does, so you have to name it, from what family or group does it come from, and how's it different than the other ones. Okay, open up the page.